Everyone, I am Yulun, and let me talk about the second part of the final year project from Information Knowledge Department. And from the first part, my groupmates have carried out the final CSV data, and let me see, it's very kind of big document. It's nearly 3 GB. And so before we starting doing our projection model, we will first do some data proposition. So let's start see our codes. So uh, in this case, we have nine planions informations in this data sets, and the last one is the total power of all the electronics equipment. And so first I will do is to divide it this kind of nine um, electronics individually. So, and I just change this kind of um, CSV data into kind of REDD format. So you can see this kind of code is just help me to take the labels on this kind of data sets, and I just take this kind of we just reading the CSV datasets. We just print out the size. You can see it's very big, and sometimes our computers cannot run very fast on this kind of huge information. So I just for need I just take only 1 million of it. The first 1 million of the all the data sets, and then I just divided this kind of data sets into out of RDD formats, and divided into 9 parts. You can see I just do this kind of things nine times. Yes, and after I have got the difference for different equipment individually, we just start out doing our main parts is just for directions, predictions. And for me, I just carry out kind of 3 methods for predictions. The one is the machine learning algorithms. It's regression tree. I just using the regression tree to do the predictions, and this is kind of the first method that we see. Uh, Before doing all the predictions, I also just take some labels on this kind of data sets, because you can see the normal datasets didn't have the labels, and I just take from F1 to F10s on the different equipments, and you can see the F10 is quite different. It's the total power, and then I just grab it. I just add the date um, date on the first in first queues for the later treatments. Yeah, and after this, you can see I just add some year dates and the title times on this kind of first rules. So after doing this, we just start our new our main part. So after doing with the dataset, we just take huge rules from this kind of things. Let's take the main rules. So you can see the houses to show you very clearly. We just take the first 3 machines to see the kind of uh, power curve. So this is 1 day curve. You can see the end of the curve is quite like this, and F1, F2, F3 is a different kind of curves, and F10 is the total powers. It's the add of the first 3 power sets. So uh, so this kind of questions is quite very simple, because it's one, two, and projection models based on the time series. So we just train the regression projection models on each planes. So this is the pictures for the total energy consumptions of each appearance. you can see F3, F1, F2 is quite very high used power positions, and F10 is the total power. So we just have a major looks, a basic look on this kind of situations. So we just start our training and test. The first one is decision tree. The first method we use is decision tree regression, and first, we will separate our hotspot data into three parts: the train parts, the validation parts, and the destination parts. These for different ways for use. So I just give one 10,000 for each part because it's quite easy to run out of the whole code. After run this kind of things, we just start doing our models, which is called the regression tree. We just build out the models, we just set up the parameters, so we just start trainings, and you can see the train time is very fast. So, and our predictions, is just we input the whole powers and we output the 9 different power of the electronics. So we just get out the 5 hairs, and then we're just using the direction models on this kind of appearance to train this kind of models. Yeah, and after training, we and the regression tree didn't have the loss, so we just carry out the train loss, not only the. You can see the train loss is quite very nearly, so it shows that our models is quite complicated, completed. So after we carry out the laws and we just starting doing our inputs and carry out the final runs, final results, and you can see the final results. We just plot out the pictures, the curves. The red one is the real values about the equipments, and the blue curve is what we have predicted. So from these threes, you can see the curve predicted the uh, by the regression methods is have a similar trend. But if one time you can see this one, if in a period times the real values have a high frequency and bounded, it cannot predict very well. So let us have the second method, which is DNN. It's kind of ways like um, doing lots of kind of ways. So DNN, this DNN I use is the fully connected DNN. It's also known as DBN. The advantage of it is that it can flat the original feature of multi-dimensional structure as input, but the disadvantage is that it has a large number of parameters and a large amount of calculations, just like the fork multiplications of matrix. So, uh, so this is the whole rules of the DNAs. Is first we just the first we just input of the data, and its input is that the regression trees is the same as the regression trees, but the output is corresponding to the total powers, is the power of each part. The next part we just is going to build out the buildings. Yes, it's build the models, and the models is also printed out. The next steps is to train and use the models to use the build model to send in the input functions, and we just establish a loss for the predicted values and the real value to carry out gradients back propagations. and last we just use our atoms to optimize the final regressions. And yes, and the beginning is kind of complicated on the calculation, so we just take the first equipment for the surroundings for for doing the kind of predictions, and you can see the laws is not very clearly, but the final terms it have some varies from the printings, but the uh, major trending is similar. Yeah, and the third way I used for is the LSTM way. This kind of way is uh, it's very mm, it's very different because LSTM models is a variant of the RNN models, and the difference is that the structure of the repeating network models is much more complicated. We use LSTM to perform the steps of retrograde predictions. First, we just construct a train and verification. First, we just this way we just constru- constructed a train verification machine which use uh, 10 100 consecutive total consumptions to predict the energy consumptions of each device. Then we just trained each applications for time series predictions and divided the prediction value and draw the train loss curve. Yeah, because these kind of ways we just carry out in the times information, so it may be reasonable, and I think the prediction prediction results will be better, and we're just doing on all the electronics, we just doing this 9 times. You can say we're just doing this this kind of things 9 times, and uh, finally we carry out the loss curves of the each equipments, and now we have the final result. You can see the curves here, you can see the curves here is quite nearly, except the third one. Okay, this kind of 4 3 6 7 is quite nearly. Yeah, it can predict very well, and we now you can also see the mean square error and the mean absolute errors on this kind of nice nine parts is also very well. Yeah. So that's the three methods of I use for predictions, and finally I think the LSTM is the best. And in the future we will try more ways to prediction, and finally we just use in the kind of new systems. So that's all. Thank you.